Hello, Mr. Jan. I'm going to explain the assignment that you have done. In the first question, we are asked to complete the traces execution of a set of instructions. For example, in T0, the program counter the value is 0400, and for T1 it's also the same. And then we assign the value of MIR to IP. It would be the same as IP, which is 0400, and the equation for this one, for the MBR, is to move n to bx, and this is it will be the value as execution. And we have three different types of flags: overflow flags, which is it's a addition or subtraction. It could be one of them, and this exceeds the range and can be expressed with a available amount of bits. We have a parity flag, which is to indicate the one bit in the operation outcome is odd or even. It could be one of them. So with the parity flag, we can indicate either the bit is odd or even. But with the auxiliary flag, it's we can utilize it, use it to carry or borrow between the higher nibble and the lower nibble, and it's used in 4 bits. In the question 3, it's mentioned that we it's mentioned we are asked to mention the 3 types of buses, which are the address bus, data bus, and control bus. In the address bus, the CPU works with its exchange data and instruction based on the address. It uses the addresses and exchange data between the memory and the input-output devices based on the addresses of the data, not the data itself. But in the data bus, we are transporting the actual data, not the address of the data, but the data itself between the memory and the input-output devices. And with the control bus, the operation are managed by the CPU and other components via control signal event over the control bus. So it's controlling managing the whole flow of data. In the question 4, we are asked to calculate the segment, calculate the delay for the cycle time in the non-pipeline and in pipeline. In non-pipeline, we have to add all the delay. We have to get the sum of all the delay, which is equal to 119 nanosecond. But in the pipeline, we have to get the largest delay, which is here is 45 nanosecond, which is the largest delay. Then plus it to the interface register, which is be equal to 55 nanosecond. In the non-pipeline system, if we want to execute it, we have to multiply the number of tasks by the non-pipeline. We have already found it, which is 119, and the tasks are 100, so it will be 19,000 nanosecond. In the pipeline, we get the number of tasks, and then the pipeline system we have found it here. It would be then multiply it, then it would be 5,720 nanosecond. Which is and this is also the number of pipeline, with the stage that the pipeline has. If we want to find the real speed up, we get this we both found it in the previous question. Then the non-pipeline execution, which is 19,000, and then the pipeline divided by the pipeline execution, it would be 3.32. If you find the maximum speed up, we divide the non-pipeline and the pipeline, not their execution, but the non-pipeline system and the pipeline, it will be 3.45. And for question 5, we are asked to explain the details for the limitations, the pipeline hazard. We have 3 types of hazard: structural hazard, data hazard, and control hazard, and each of them has a cause and the solution. The cause of structural hazard is that it's occurs when 2 or more instructions in the pipeline have the same hardware resources simultaneously, which means the same time. So we have to add more hardware resources or schedule resources to so it's sufficient. In the data hazard is occur when the instruction depend on the result of the previous instruction that are not yet completed. So we have which is dependency between the instruction. For example, we have instruction 1, and the result of this instruction depends on the previous instruction. So to solve this problem, you use data for the installing and instruction recording. We can forward the result from later or pipeline stage directly to an array stage, or we can delay the dependency instructions until the required data is ready. Then we have the third one is the control hazard. The control hazard occur it's happened when the pipeline is not sure, it's uncertain about which of the instruction to fetch. It's not sure. For example, we have many instructions and it's not sure, it's uncertain which instruction to fetch. So it occur. This control hazard is occur, and to have a solution to this, we can use a hardware to predict the outcome of branch and prefetch the contract with the correct instruction.